Good afternoon. How are you? My name is Camille Chisholm, and I am your instructor for Packaging 450, Industrial and Automotive Packaging. You will see on my screen a little bit about my background. I want to introduce myself to you all. I went to Michigan State for my undergrad and also went to RIT for packaging. And I have over 30 years of experience in the packaging industry. I've worked in food, pharma, distribution, sales, computers, automotive, a little bit of everything. And I am certified with IOPP as a certified packaging professional. I was inducted into the College of Fellows with Institute of Packaging Professionals. So I hope you all are involved with that. And I have done things like receive my Lean Six Sigma Black Belt, value stream mapping, things like that related to automotive packaging. And I own my own packaging firm. So I work a lot with automotive. So this is perfect. So I am looking forward to sharing all of my experience with you and sharing some of the best practices for automotive packaging. So it looks like we had someone join. So again, these are live recorded, but if you, most of the time they will be live recorded. If for some reason you're available and you'd like to join, feel free to join in. This is a chance outside of office hours, of course, and emails to ask me questions or interact with me during the live stream. Hi, Brandon. Feel free, if you have any questions, unmute yourself and raise your hand. I am just started recording and you are right now the only person on. But like I said, anyone's free to join. So if you have any questions, just just step right in. Okay, so next, so that's a little bit about my background. One of the other things that I just wanted to really kind of go over before we get into this is to talk about automotive packaging and how it is similar to other functions or other industries. So, and what functions come into play. So, for example, with food, if you got regulations, you got performance, you want to make sure that the product is safe for the consumer. That would be one of the really big things in automotive that is similar to food. Technology, the cars have a lot of technology in them. So any packaging that you're looking at for technology products, you're looking at the same thing for automotive. Compounding pharmaceuticals, again, this has to do with safety and really how important it is to make sure that you have precision and accuracy in the product that is being brought in for the consumer. As far as functions, I put a list of functions here and the items that we're actually going to be touching upon, most of them or something that's very similar to them. So for example, for returnables returnable packaging is used in other industries. However, it's very, very common in automotive. I even have a recording that you all will see later from someone that I met recently that was actually working in automotive when returnables were instituted in the 80s. And a lot of people were not around when it happened. So he gave really interesting perspective. Testing. There has to be a lot of testing prior to the rollout of the packaging, because with automotive, one of the big items is if you stop the line, that's a problem. It costs a lot of money when you stop the line. So you want to make sure that the packaging is flawless and the packaging keeps the product flawless so that when packaging gets to the line for assembly or for shipment, that you don't have any damage or any issues that will stop the production. Business development, it's important because in packaging, you work with a lot of salespeople, or maybe you're looking at becoming a salesperson on the packaging side. And if you're working with automotive, it's really important to understand how that process works. It's a little bit different than, say, food, in that a lot of times if the suppliers work hand in hand with the food companies and they drive some of that technology. from the automotive side, from a business development standpoint, dealing with packaging. Automotive is very focused on cost, so there's not a lot of profit or margin involved. So when you're dealing with packaging and business development in automotive, you're really focused on the performance versus getting a profit out of the packaging. Protection is very important. As I mentioned before, you don't ever want to shut the line down. And as we get more and more technology in the vehicles, there is more and more protective packaging that you will see. We have things like foam, fabricated foam, molded foam. There's something called a gel pack that I'll show you samples of that later. I will keep samples handy. I have a lot of miniature samples, so I'm a very verbal and visual person, so you can see some of the things we're talking about. Food, I listed that there because of all the regulations and not wanting to stop production, making sure that things are safe, in the standpoint of packaging. Logistics, supply chain, and distribution, you will find that in automotive packaging, packaging works hand in hand with logistics, supply chain, and distribution, partly because of the returnables and the importance of the supply chain for that, but also when you're dealing with inbound parts, a lot of automotive uses just-in-time manufacturing. So it's really key that packaging is tied in with the logistics side of the process. Manufacturing, I'm going to keep saying you don't want to shut the line down. So you want to make sure that you're working hand in hand with the manufacturing team. You want to be proactive from a packaging standpoint versus reactive. And you'll hear about that as we go through this course. Project management, because automotive is driven by programs and projects and vehicle launches, the project managers drive a lot of the activity before the packaging, before the product is launched. So packaging has to be involved early on. So it's really important to develop relationships with the project managers on those teams if you work in automotive. And then research and development. Automotive has traditionally been a, React, get it out there, and, we'll use whatever packaging we have available. But as we get more and more technical with a lot of the componentry that's going into vehicles, it's really important that packaging gets involved from a research and development standpoint early on, driving even, new innovation in packaging when necessary that will help the product get to the supplier, or get to the manufacturer, or get to the assembly, or get to the customer in the manner that it needs to get there. Okay. Bear with me, I'm going to switch over. Next, what I wanted to do today, I wanted to go over after my introduction, I want to go over the syllabus. And then I wanted to start into chapter 1, and then I'll wrap up a little bit talking about homework and some of the logistics. So if there's any questions so far, Brandon, let me know. Okay. Let's see. So while I'm switching over to the syllabus, Brandon, I'd like to hear a little bit about you. I know we're probably going to talk later, but I'd like to hear what prompted you to take this class.
Yep, can you hear me?
Yes, I can.
All right, cool. Currently sitting in this Starbucks right now, so. But yeah, I wanted to take the automotive packaging because I was doing mechanical engineering with an automotive concentration. So, I still wanted to get the little taste, learn a few things about the automotive industry. And I'm currently working in industrial packaging. I'm out here in Cleveland working for Stanley Black & Decker. So it's a lot of crossover with that as well that I want to use during my internship.
That's great. That's really interesting and great to hear. So are you an engineering student, or are you in the packaging school?
Yep, I'm in the packaging school.
Okay, so you made the transition over, like a lot of people do. Yeah, and
Definitely.
you'll find in your career, you'll come across a lot of engineers that end up switching over to packaging. They just fall in love with it. So you'll find that throughout your career. Okay, I'm going to share my screen again and go through the syllabus. Okay, just make sure you can see my screen.
There
Okay.
we go.
Okay, great. So I put the syllabus together. I'm trying to keep it, fairly stable. One thing I know automatically I need to update is the Zoom link, because since today was first day of class, I did not have access to the Zoom, MSU Zoom until today. So there might be a few people on the old Zoom. I probably should double check that just to make sure. But I want to go through the syllabus. Like I said, I'm going to try to keep this. I'm just checking to make sure that no one has joined. So day one, working out a few of the kinks here. Okay. I think we're okay. All right. So again, want to keep this pretty stable. I will update the Zoom link just to make sure everyone has it. Probably looks pretty standard compared to a lot of the other syllabuses that you'll see. First and foremost, I want to make sure that, when anyone is listening to this lecture, this course is a 3 credit hour course. Everyone should have done this already, but just in case there's anyone that hasn't done this, this class is going to consist of 2 credits for PKG 450. And then there's going to be the one for 491 special topics. That's 1 credit. So then this will equal 3 credits. So if anyone's listening to this lecture, watching this lecture, and you realize you only have enrolled for packaging 450, then you need to go talk to Aaron, in your advisor, and make sure that you are signed up and enrolled for packaging 450. Otherwise, I think it will actually kick you out of this course pretty quickly. Okay, so meeting days. For the lectures, I will be live recording most days. There may be a day or two where I record ahead of time, but the recordings in general are scheduled for Tuesday, Wednesday, and Thursday from 2 p.m. to 4 p.m. Eastern Standard Time. So that's 6 hours a week of lectures. So I think most people are probably going to look at these later, and you can always go back and view them again. The link will be changed for the Zoom. That's the one that I'm recording from now. I'll make sure that is updated in the syllabus. It's already on the announcements. Here again is the course recording schedule. And here's my information. I am going to schedule office hours from 4 to 5 on Fridays via Zoom. So the location is the Zoom call. If you need to make appointments with me and you cannot jump onto the live lectures, or which again, the live lectures are purely optional. As long as you listen to them, you don't have to attend, but it's just an extra thing if you want to ask questions or listen. After hours or outside of office hours, you can always email me to schedule. Here's my telephone number. You can call me. That's my cell phone. You can call me, or you can text me if you need to. And once again, I put it in multiple places with the Zoom call. I will use Zoom for office hours as well. So I will use the same Zoom link that you have now. Description, this course is an overview of automotive packaging principles. You're going to learn about the history of packaging, even in history of the automotive returnable packaging, get an understanding of the processes that are involved with how vehicles are manufactured and how packaging ties into that, and understand that the role of packaging in the automotive manufacturing process is key and how it ties in. You'll learn also about types of containers, standard containers, what parts tend to go in specific type of containers, how they're designed, how they, make sure that the packaging is protecting the parts, the types of parts that are used, information on locations of suppliers, a lot of information. You kind of get a broad overview of the landscape of packaging in automotive. And also, we'll talk about the whole process of returnable packaging versus expendable packaging. It's not in here, but I'm going to add it as a supplement to read. As it's not going to impact your homework. But recently, just within the last few weeks, a paper was put together to talk about sustainability in automotive, and they're working on setting standards. So I'll make sure that you all get that and that you can read it. And like I said, it's not tied into the homework because it just came out, but it's pretty important, and it's something that the automotive industry packaging people are actually working on. So it's very pertinent, very timely. I mentioned this before, that the course is online. The recordings will be live, optional attendance to that, but you can review those Zoom recordings at any time. Homework is due every Monday morning. You'll see the time, Eastern Standard Time. And the grade for this course is based purely on the homework. There are no tests, there are no quizzes. It is all of the homework assignments. So, feel free to reach out to me with questions at any time. I'm going to bake some time in after the assignments are turned in to go over some of the answers. So, anything that people have an understanding of, or they have questions about, you'll have the opportunity to go over that as well. The homework is based on the reading assignment. So the chapters that you have that are posted in D2L are what the homework is based on. The videos and readings that I send are supplemental to that, just to give you, more up-to-date information on things that are going on, like sustainability, or like I said, the person that I met that had a history of returnable packaging and how that came about. So, those things are all important, but the homework is outside of that, just so you know. No prereqs for the class. All the course materials will be available in D2L. Most of them are in there now. I might tweak things from time to time before I put them in. But once I put them in, they will, according to the schedule, I'll put them in a homework assignment. When you see the homework assignment, once it's in there, it won't, and there's a due date for it, and we're on that chapter, it won't change. So for example, chapter 2, once chapter 2 homework is in there for the beginning of next week, when we start on chapter 2, it won't change. So once we start the chapter 2 work, I won't change the questions or anything on the homework. I think internet requirements, access to D2L, have an internet connection, even if it's Starbucks, and MS Word and or Excel. So I prefer that you do the homework in Word and or Excel. So everything is put on in Microsoft. Mentioned before that the course is delivered online, and you go to D2L and access it. If you have any questions or issues with it, you can reach out to me, or you can reach out to technical assistance that's listed in the syllabus. I think most of the things in that are left in the syllabus here. There's things for people with disabilities. If you have any questions or need anything for that, you can go to the links that are in the syllabus. Instructional objectives. I think that I probably covered this a little bit already in the beginning when I gave the introduction, but I want to make sure that you are able to understand the terminology and the concepts that are related to automotive packaging, really see and understand the processes that are related to automotive packaging and also automotive manufacturing, because it's really important to understand the manufacturing process. And I know a lot of people are probably, familiar with it already, being from Detroit. probably my father used to actually take us on Saturday mornings for tours for fun. So I know that's, sort of woven into the fabric of a lot of people in the area, but just want to make sure that people have an understanding of that process if they're not familiar with it. And then just how it ties in into packaging and the automotive process. The next objective is to determine when returnable packaging is needed and when expendable packaging is better. How to make that determination from a standpoint of part type, part protection, part use, the manufacturing structure, as well as, doing some sort of ROI, making sure you understand, return on investment and what your expenses will be. And then the next one is the other objective is to understand and have a basic framework so that if you do decide to work in automotive packaging or, industrial returnable, which are very similar, that you can go in and, structure things, set things up. Many times I found that there may not be a structure. People have just been working and getting things done and powering through things. But part of the packaging engineer's job is to build some order out of chaos through packaging. Here, I just want to make sure that, you basically need to complete your readings and your homeworks and listen to the lectures. And if you have any questions, you can attend the office hours, or you can set up separate office hours with me, or you can come on to a live recording and ask me. So there are plenty of opportunities to reach out to me. As far as the schedule, it's going to go week by week. Each chapter is going to be the next week. So the first week, we're talking a little bit about the history and background of automotive. Next week, we're going to dig into returnable containers and program management and how packaging ties into the vehicle launch process. And the next week, we're going to talk about the importance of testing and the role testing plays in packaging design and even part approval, because the whole process of approving parts, usually there is, at the very least, there's a checkbox somewhere that says packaging has been completed and approved. So you want to make sure that your packaging has been designed, reviewed, tested, and approved before, say, the quality team comes by and does that check mark, because once that happens, you may be stuck with the packaging and then you're fighting fires for years on a specific pack. Week 4, we're going to talk about container selection, understanding, for different vehicle parts, what type of protection is needed, and then what some of those traditional packs are in automotive for those parts. And then there are ways to estimate the size of the pack, what's the best size to use. Are you going to ship something in a bulk pack like this, or you're going to ship it in a tray that holds parts? Are you going to use an expendable pallet that you can, get rid of, or you're going to use a returnable pallet? So, those are some of the things that we'll talk about for. Week 5, we're going to talk about the return on investment, how to calculate what your costs are for a returnable versus an expendable pack. And then also, how to justify that. And then also how do you determine how many you need as far as packaging if you are shipping in returnable packaging, because there's a whole process on how to determine how many packs you need. And there are, various versions of fleet calculation. So I'll go through standard one that's very basic, but then I can go through some other ones that, and just show you some of these other calculations and what would factor into some of these other calculations. And then week 6, we'll talk about rental companies and standardization of packs. So rental companies push that, you don't have to manage your packaging the way you normally would if you own it. They can keep track of it. They also can, one of the advantages they say is that they can give you standardized packaging. There are some other disadvantages, and things that you need to be aware of when you're looking at rental companies, particularly related to cost and some of their cost models. And then, week 7, I think we're just going to have one day and we're just going to be wrapping up and answer questions or anything like that you'll have. This is the schedule. So you can see we have the topics and what you're reading for each chapter that's going to be in D2L. And then the activities for that week. So for example, this week you have assignment 1, and then at the end of chapter 1, there is a link to a video that's part of the Ford Rouge plant. It gives some history. It talks about the Ford plant because it's one of the first manufacturing, full-scale automotive manufacturing plants, and some of the innovation that went into play there is actually still used to this day across automotive. It's about an hour-long video, but it gives a really good background of automotive. So those are some of the things. I am probably going to add a couple of things in here and activities, mostly reading, maybe a video or two for you to see. But most, again, the assignments are going to be based on, the grades are going to, that's what your assignment's going to be based on, would be the grades. I'm sorry, your assignments will be based on the grades. Here's the grading policy for those assignments that I just mentioned. The points is going to add up to 300 points, and they are due on Monday mornings at 10 a.m. Eastern time. And that's listed here as well in the syllabus, but they'll be due in the morning. I think it's also in the calendar in D2L, and you'll see how the points are broken out. So you got 300 points possible in this course, and you can see what the grades are between the points that you received, the percentages as well. And then I think the next, you've got policies in here. I think these are all pretty standard. If you have any questions on any of these, like Spartan Code of Honor, mental health, any of those things, you can click on. These are all clickable links. Academic honesty. I will say that for this class, we are expecting people to work independently. So, I don't expect to see 5 people turn in the exact same assignment. So, I'm sure there might be some discussion amongst your friends, but I expect that everyone will be turning in their own homework with their own work. Again, some general information. This is all standard. If you have any issues with anything that you might see, as an instructor, I'm a mandated reporter. So I want to mention that if you have any issues and you need to be referred, if you want referral to the counseling center, or there's an issue, just feel free to let me know. I'm here for that. I'm here for you. If you have any accommodations for disabilities, let me know as well. There are no materials from this course that are coming from the bookstore. You don't have to buy a book. You don't have to buy anything from that. There's nothing that is, anything you need to purchase online or anything like that. Disruptive behavior. I think really the only thing that probably could happen with this, live recorded class is someone coming and disrupting the lecture. I think with Zoom, that's pretty easy to fix. So if someone is disruptive, I will just, remove them from the meeting and deal with it from there. Attendance is not required. Like I said, everything is recorded and you can view them at your convenience. But, I tell you, I'm recording this live, so you have the opportunity to join if you need to or want to. This class is structured so that the students do not have to join, but I thought this might be something that will help them, to next session here to build rapport, or just have the opportunity to ask questions as I go through these lectures. And the final one is, I'm expecting you to watch the lectures during the week that the information is recorded and presented, and to go along with that same homework. If you have any questions, feel free to let me know. That is the syllabus. So Brandon, you're the lucky winner today. Do you have any questions on the syllabus?
Oh, don't have any questions on the syllabus.
Okay. Comments? No. Okay.
No comments either.
Okay. All right. I will moving on to the next item. I just want to make sure that I have everything here. So next, I wanted to start into chapter 1. For some of these lectures, I will have some PowerPoint information, but for this chapter, I think that we've got the information that is from the chapter that's really good, and then looking at that Rouge course for information, I think that information is really good too. Okay, I think I just closed it. So technical difficulty here, bear with me. Yeah, I just closed it. Okay. Gotta have one glitch recording before we get started. Okay. Okay, here we go. So chapter 1, like I said, I'm just gonna kind of go over through here because I think there are some really good pieces of information and pictures in here. So you will see this when they talk about like automobiles, how they were built. This will be in that Ford Rouge video. I think there are a couple other links through chapter 1 as well that were in there. But again, initially, and you'll see this still with cars like Porsches and Ferraris, they tend to be built, Lamborghinis, Bentleys, they're built more individually. So they're handmade, that is how automotive worked early on. Even in Detroit, when you look at some of the history of automotive, they used to have these workshops. So, like now everything, so you have Stellantis, which was, Fiat Chrysler. But when it was Chrysler, you had like Dodge and, other various brands within the Chrysler realm. Those all used to be separate companies. So you had like the Plymouth group, they were a small shop, and you had the Dodge group, and then they eventually merged. But early on, these were handmade and they were very competitive with each other. And if you actually read about the history, this is another off topic, but if you read about the history of automotive, there actually used to be a lot of conflict and competition amongst these small shops. So prior to that, like I said, you had things that were handmade, things were being built one at a time. The car stayed in one place and they added the parts onto the vehicle in that spot. Now, when you go into any automotive plant, you will see the automotive line moving the vehicle down the line, and they're adding parts as the vehicle moves. So the car moves to the station for that part, whereas before the parts moved to the vehicle and the vehicle is built in a stationary manner. The assembly line, one of the benefits was that, they could make more vehicles, and it also allowed, for the speed and more precision, because you're the same person putting the same part or doing the same function all day. So they became an expert at it versus, having someone that would build the same car, they would do, 20 different things. And now you've actually increased the precision and you've sped up the line. and you can have people, doing multiple things at the same time. Like, so for here, for example, it talks about putting the doors on and the windshield at the same time. Whereas before, if you had, something where people were building that they'd have to go get the windshield, put it on, they have to go put each window or each door on separately. You'll see this line here. It looks like an old-fashioned line, but this was actually the beginning of an example of where Ford started to automate the line and move the vehicle down the line and have people specializing in what they're doing. So he's, the Ford company is credited with this. This was a major change and revolutionary in automotive. And in fact, not just automotive and other modes of manufacturing, a lot of other companies and other industries adopted the same process. Rather than having a workshop, they turned things into an assembly line with stations to build versus and the product or the part moved through that manufacturing process versus building one thing at a time in the spot. So that was revolutionary, not just automotive, but to manufacturing. So I'd say it was a step from a new step in the Industrial Revolution that it helped move things along even more. Okay, here is an example, and I think all these pictures that you see, they're all from the Rouge plant in Dearborn. So you can see this picture, very old, but you can see the vehicle coming out. This looks like maybe a Model T. I think it's a Model T. So this was one of the first vehicle lines that Ford built, was the Model T line. But you'll see over here that these carts, they don't really look that different from what you see in the manufacturing processes today in automotive. Okay, so here's a modern assembly line. While you don't see these carts here this close, I will tell you that these carts are back here outside of the line of sight. So I think one of the big changes you see now, you'll see all the packaging is right at the line so that the operator can reach it. And we'll talk about that later. So you'll see here in these two lines, the people are standing around and then they push the vehicle forward. You can see the cars on a roller system and they can roll it through here. And same thing at the end of the line here, they're bringing it off of a ramp. So they're basically working from the floor. But you'll notice now the newer lines that everything's on a plate. So if there's something wrong with this vehicle, they actually could take this, depending on the manufacturer and the line, in some areas, they could take this whole plate out and move it out if there's an issue. Or they can just take the vehicle out and keep everything else moving. But the old lines had some kind of a chain, like a conveyor system that would pull the car along. And now this system is called a skillet. It's like where the plate, they can take that whole 20-foot by 10-foot plate out and or just move and do all the work on that in that one cell. And we'll talk later about material handling equipment. This one is used for cars, but it allows, depending on the station, that can lift up or down so that if someone's, say, working on something like the sunroof, that material handling equipment will move down so that the operator can get on top of the car. But if they're installing something lower, like a floorboard, or maybe they're installing something at the underneath or at the base, that material handling system will lift up and then they can install from the bottom. So the whole goal is to keep the operator standing pretty much in their very similar position. They're not taking a lot of steps, because the more steps they take, the longer and more time it cuts out of their day, and they can do less work. So the whole process is to keep them so that they're standing in the same position, and they're not really moving a whole lot. So that's why it's important. They can move the car up and down, and then you can see the packaging in the background that they can actually pull those parts out. And you can see it at this station, the vehicle's up relatively high, and you will see that the bins, those bright green bins in the background, they're also pretty high, which means that the operator is going to be reaching for them. It's very easy for them to just reach and grab, and they're not struggling or straining. So they're not getting down, bending down, they're not climbing up something. They're pretty much, everything's all at the same level. Okay, this is interesting. So if you were to take a vehicle apart, you would see a couple thousand parts for every single vehicle. I've worked in automotive seating, so you see these seats here, you're gonna have anywhere between 300 and 500 parts alone just for the seat. I worked for an engine plant, and they had hundreds of parts for the engine easily. So I don't see the, oh, here's the engine right here. So you can just see how many parts there are. And that includes every single part. Like here, you can see these are fasteners and washers. So every screw, everything is counted and used and has a part number. So you could use the same screw here, same supplier, but the screw that it might be the same screw or fastener that gets used for the steering wheel, and that may have a different part number. So that's something else that you have to keep in mind, because the part number can affect the packaging, even if it's the same part, because the part number may be driven by a different quantity. So over here, you might be using 8 of these fasteners, but over here, you might only be using 2. And over here, you might be using 20. So that is going to affect the type of packaging that you select for that part. Another thing that you have to look out for, they mention here that you might have 10 part numbers, but the color's different. So when you got things like seating or the doors or cup holders, armrests, those things might all be different colors. Or you might have what's called a left-hand part or a right-hand part. So you would have a left-hand door handle and a right-hand door handle. So they look exactly the same, except they're mirror images of each other. So when you look at a vehicle and say, I have a door handle, you could end up with an SUV, you could end up with, say a van, you might end up with 12 parts, because you've got 3 on one, if you've got 3 doors, 3 passenger door handles, 3 driver door handles, that's 6 right there. But then you start looking at colors. So if this car comes in black, white, red, orange, green, purple, and for each one of those, now you can have up to 6 different part numbers depending on how they're structured. So it can be very complicated. So you might have, 2,000 different part numbers, and that could actually, it could proliferate because of color. So you have to be aware of that too. So you might have something that's low use. Let's say you have, yellow, a yellow door, a yellow car. You're not going to sell that many yellow cars, but if they sell that car in red, you might sell like 1,000 times more. That's going to impact the type of packaging that you select for those. But it also gets tied into the room that the space is allocated on a production line. So a lot of different things to take into consideration. Okay. Next, this is an example. This is an engine line right here, and you can see various things. So for one, you've got a monitor. This monitor here might be giving them instructions on what to build. It might be telling them what parts they need. It might tell them, how many they've done in a day. Maybe they need to do 1,000 get 1,000 vehicles done or 1,000 engines done for their vehicle orders that day. And it shows them that they've only done 300 and it's 1 o'clock in the afternoon. So, they can get engaged there. There might be a lot of information for them. Here you can see another example of the packaging line side. So you'll hear comments like line side packaging. There will be packaging that is made to fit right near the operator when they work so that they don't have to go walking and getting packaging. And you'll actually hear about this a little bit in the video that for the history. This is an example of a just-in-time assembly plant. So we'll talk about that as well. These parts are ordered by, okay, so for example, when I worked in the seating plant, the plant was down the street, 5 minutes away from the OEM. So the OEM, the original equipment manufacturer, would be what we consider the big three, like Chrysler, or which is now Stellantis, Ford, General Motors, but it could be Toyota, Honda, any of the vehicle manufacturers. They're considered the OEM. They could put in an order to their part supplier and say, depending on how they're setting up, if they're more of a lean manufacturing company following the Toyota principles, they could get an order that says, our customer down the road 5 minutes away wants to get 50 of the black doors today. And only 10 of the, or 5, let's say 5 of the yellow doors and 50 black doors. Every day they've been ordering 50 black doors and 10 yellow doors, or 5 yellow doors, very low volumes of the yellow. But then maybe they get an order from Yellow Cab to buy vehicles for them. So now they might decide to put in an order for yellow doors. So while they've been ordering 5 or 10, now all of a sudden they might order 100. And if it's a just-in-time plant and they're using just-in-time assembly techniques, then the plant will be set up to accommodate that quick order, because that turnaround might be an hour, 2 hours, maybe 3 hours at the most. But they're set up to be able to accommodate that change from 50 black to 5 yellow to 100 yellow within hours. And they are supposed to, they will know like how many parts they need, how many parts they have on hand, if they need to order anything to get anything in to get those orders met. They have made agreements with their either warehouses or their suppliers to get things very quickly. So just in time is, it's efficient for the OEMs and even the larger manufacturers, which say the tier ones are supplying to the OEMs. For larger companies like the tier ones or OEMs, just in time works well for them because they get what they need when they need it. If the further down you go downstream for the suppliers, it becomes much more challenging and very challenging for them. And in order to do that, here's where I mentioned on lean manufacturing. You heard me mention about steps and taking steps and why it's important for the operator to stay in the same spot. In the automotive world, and you'll see this in other manufacturing facilities too, say if they do a time study, but lean manufacturing, they may not do a time study. They will do things like a spaghetti chart, or they'll count the steps, and they'll see an operator all day. There's operators at the line and they're pulling parts from the bin, and they're standing in one place and they're able to pull those parts from the bin. But there may be one station where they see the operator has to go walk around, get parts, and come back with parts. And they see them doing this 20 times a day. That is a red flag that, they need to implement more lean manufacturing processes to make it easier for the operator to get these parts. The reason why that's important is because if they get an order where all of a sudden they go from 5 to 100, they've got to have very streamlined processes so that they can switch, and they're not focusing on going and picking things up and walking down the aisle to go get parts, they'll be set up so that now they've switched over to yellow. Operators, the people that are delivering to the operators, they'll get a signal that will show them, you need to go get yellow parts right now. So right here, where I was showing you this monitor, this could be telling them, how many parts that they've done. But then if there's a very quick switch over for just in time from the black doors to the yellow doors, they might get a notification on there. So they're not going to build like 10 more black doors. They're going to stop, and they should be able to turn around and grab their part, or their part should be right at the line. So you'll see right here, this looks like some blue bins. These bins might hold parts. So if they're changing something, there will be people that are assigned to deliver parts on time. So if they get that just in time order change, technically the operators that are building, they shouldn't have to stop what they're doing. Those parts should be coming right to the line in the right packaging, and they can just continue to work. The next part that they pull should be the right part. So it eliminates a lot of that. Their job is to install the part on the door or the engine or whatever that part is. That's their job, is to install that part. And there are other people whose role is to make sure the right part is there at the right time. So that's part of where they talk about eliminating wasteful activities and, with just time delivery. Here, traditionally, we talk about receiving parts about a day before they're needed. Some of the OEMs are very demanding, and they might be giving what's called a signal or a change in order of an hour, 2 or 3 hours ahead of when they need it. So in general, they try to have a day's worth of parts in before so they can accommodate changes, but some of the customers are very demanding. And you have to understand that if you're in automotive, what the suppliers require. So you might be like, when I work for seats, some of the companies, you were fine with having a day's worth of parts ahead of time. Some of them you needed 5 days ahead of time. Some of them you needed to be able to switch up an hour ahead of time. So it really depended on that supplier and what who their customers were. Okay, I just talked about this a little bit about the operator at the line who's installing a part. Their job is to install the part, and they shouldn't have to worry about whether the right thing is there. They will have ways to check. So with lean manufacturing, they will have things that they can check, things that they can look at. Visual management, where they might have the screen that tells them, flashing, something's about to change, or they might have a different color, they have a flag that comes, they will have some way to know. But so they'll have something to say, hey, just in case this didn't happen, we're letting you know it should happen. But in general, they shouldn't have to worry about that. And that's because what's called sequence part delivery. And the parts will get delivered where they need to be, when they need to be delivered. And, this gives an example of dealerships, but in the automotive manufacturing realm, many times it could be your vehicle auto OEM that's asking for a request for orders very quickly. And then by doing this, it does help, to reduce errors, because they're not worrying about I got to make, 1,000 doors, and you're so busy making 1,000 black doors. All of a sudden, when the machine says yellow, they just keep making the doors, and then they've made, 300 too many black doors. Now, what do you do? But when you're looking at things that are sequenced, the order of what is needed will be, listed from a computer, or the operators will get parts delivered to them in the order that they need to be. I think a really good example of this would be radio systems, or, like the sound systems for vehicles. So if someone orders a specific option for their vehicle for the sound system, it will show up in the order. So it'll say car number 7 today, they're getting the deluxe stereo, the deluxe sound system. Car number 8 is going to get the sound system where it has a Bluetooth for their phone. Car number 9 is going to get the Apple package, or the package that goes with their iPhone. So they can actually specify orders to that level of detail. So that is the beauty of sequencing. This kind of goes into some of the things that I talked about. I just gave some examples of communication. There's communication, via electronic notification, but then, you have paper communication, but then you also have the visual communication, where I mentioned the visual management, where they might see a red light flashing on the screen to say, we have an error, we have something wrong, or we've changed something, notice we're getting ready to do a changeover on the line to do something different. It also helps them by being able to trace things. So I mentioned the sound system before. If they find out that, maybe the sound system changed, or maybe there's a recall, or as we know with the pandemic, that, with the chip shortages, maybe you have a group of vehicles that the components were put in, but they don't have the right chip, or they don't have a chip. They can actually, with the communication systems that they have, they can actually separate those out, build everything else they need, and flag them so that they don't get shipped out. As they would just come right off the line and get put in the truck. So if you compare what I'm saying now with some of these systems, and I'm going to go back here to something like this, if you had something that went wrong, you wouldn't necessarily know how to find it. It might take a while, because now they've got to go find those vehicles. They may be parked in a lot somewhere, and they've got to visually walk over there physically and go through. Maybe they have paperwork and find it. It's going to take a lot longer, and they may not find it until it's maybe to the customer, or it's on, it's parked out somewhere before the customer gets it. But with the current processes like this, they can actually find those things and pull them before they even get out the door, before they even get off the line. Okay, so a lot of this that we're seeing, is talking about the high volume assembly plant can produce about 72 cars per hour. So that's more than one a minute, right? So I'm gonna date myself, but when I was a kid, my father would take us out to vehicle plants on Saturday mornings for fun. And it was very slow moving. Like now, you can walk across the line when the vehicles are moving, but you've got to really watch. You might get, the vehicle might come at you. Versus back then, even though they had the production line, it wasn't that fast. People walk back and forth in between to get parts, and it wasn't as fast moving as it is now. But again, you look at the volume, is considered high volume. They're doing 72 an hour. Some of the suppliers, like when I worked for an engine plant, they could make 1,000 engines a day. So they're supplying the multiple plants. They're not just making 72 an hour for one vehicle, for one plant or one vehicle. They're making it for multiple types of vehicles. So this gives you an idea of, how you can maximize your production. So with this part here is a pretty good calculation of how many cars they can do a day. So here they're doing, a little bit over 1,600 cars per day. And that's including like breaks, people covering for breaks, lunch breaks, any maintenance, because also keep this in mind, when you're determining how many packages you need, when we get to the returnable portion, if you're working in automotive packaging, once you start working, you also want to understand like how much downtime they have. Downtime could be breakdowns, downtime could be breaks, but downtime could also be what's called PM, or preventive maintenance. So they can plan for, replacing bearings or replacing things or going through and lubricating something. And those things are planned. So they will have a planned shutdown on the line. So you have to take that out. That would impact, how that could really impact how big your packaging is, how many parts you need in a pack, how many packs you're going to buy. So just keep that in mind. You want to understand all this so that you can really know what type of packaging works best for your line. Is it high speed or low speed? Is it bulk? Are you going to be using, a bulk bin like this? Or are you going to be using a small tray that carries a bunch of parts like that? Knowing things like, the breakdown, how many parts can be made on a particular line, as well as what the demand is of that line is really important. Okay, so remember I mentioned before about the assembly line being a stress-filled environment, or you don't want to shut the line down. That's kind of what that means. If you shut the line down, you can see here, the cost is $10,000 per minute. So no one in the automotive plant ever wants to be the reason why the plant was shut down. I've worked in plants where they have helicoptered parts in. They can't find the parts, they will go, or they'll hire a helicopter to bring the parts in. Now, you don't want to do that. That's a really last minute scenario, and it's expensive to do that. But they would rather helicopter parts in than shut the line down, because it's so expensive to do it. I put this picture in here because, this talks about how if you can either shut the line down, you don't have enough parts, or maybe you end up with too many parts. You got to really know how many you're ordering, because if you have too many parts, then you can have trouble finding them, or it can actually cause a backup. This picture I put in here because this is a plant that I used to support. And you can see this is out, this is all highway, and this is the plant. This is the back of the plant, right? When you pull into the plant, it's very neat now, but I remember coming to this plant, all of these trucks here, these are 53-foot trucks. So the doors are full pretty much. I can see, yeah, there might be less than 5 bays that are open, where there's a truck. But every one of these doors is pretty much filled with a truck that has parts in it. And I've actually had to go into this plant and look for parts that I was looking for. And it said, oh, it's in, trailer number 7, but it was really in trailer number 20. So because they had so many parts, they were trying not to shut down, because this was the plant that they had to respond into somewhere between 1 and 3 hours when there was a change from, they would 70% of what they made was part A and 30% was part B. And then the supplier would flip and go, oh, we want what we hardly ever order. Now we want 70% of that and 30% of this. So they tried to do things to counteract that. Instead of having, more lean manufacturing processes, they just loaded up their yard. But with that being said, this whole right here, this whole street and highway was filled with vehicles. And then they even have a lot back here that was filled with vehicles, or the 53-foot trucks is what I mean when I say vehicles. So, first, you don't want to shut the line down, because you got a lot of cars that are sitting that don't get made, that people are waiting for orders from. Then, I mentioned that they have the capability to pull the vehicles off to the side, like for chips, but that's if you see plants and companies doing that, it's their last option. They don't want to do that because they have to go back and it's very expensive. Now you have to hire extra staff or bring up extra staff in to finish the vehicle, because the people that normally would have finished the vehicle are inside finishing new vehicles that haven't been finished, so that are still on the line. So you got to actually bring in extra people for that. So it can be, very expensive. And then if you're bringing in people that you don't normally bring in and they're doing the work offline, and it's not in their regular station, they're more prone to errors. There's more chance to have an error by doing that. So a lot of things really lead into this and tie into this. Okay, I'm going to take a break now. Quick little break, water break. Brandon, I'm going to ask you again since you're on. Any questions or comments right now?
Lexi, I did want to mention earlier when you were discussing the lean manufacturing.
Mm-hmm.
So is that pretty much just based on the whole aspect of continuous improvement within the workforce? That's that whole area?
Exactly, yes. So
Okay.
the whole process of continuous improvement, you can always make things, you can always improve a process. You can always look at, how can you change this process to make it even better. So it doesn't mean that your current process is bad. It just means that there are always opportunities to improve.
Okay, cool.
Yeah. And there are, if you're interested, I can recommend some books and things that are good to read for that. But or even some websites that are good.
Okay, I'm down. I just recently got my yellow belt and I was looking forward to actually continuing that whole process. So I'll take any notes I can.
Okay. Yeah. Yeah. There's a lot out there for that. So it's really interesting. Once you start really looking at it, it's interesting because you think that way in no matter, what your approach is, whether you're in the plant or whether you're making food or whether you're at Panera and you see that the coffee and the creamer need to be flipped around, because everyone's walking over each other. It's just really funny how you have a different viewpoint once you start doing lean.
Yeah, most definitely. A whole different mindset.
Mm-hmm. Definitely. Okay, so this is from 2019. This is a listing of part suppliers globally, just so you get an idea of how big they are. Generally, I mentioned that I supported a plant, the one I just showed you, and they were just a couple miles from the OEM. So you'll find that where you see an automotive vehicle plant, there will be clusters of suppliers. And that's because, they want to be close, shorter trip. They have more access to parts. So let's say that, in Michigan, it could snow. The chances of these parts getting stranded and not being able to get them to them is much less during a snowstorm if they're right across the street versus if they're 50 miles away or 200 miles away. So this is just to give you an idea of, the size. It looks like that ranking hasn't changed. This is 2019. I'd say it hasn't changed much. When I look at the companies that I've dealt with, I've not worked really with Continental. I know a couple of people that work there. Yeah, I've worked with, I think all of these with Vallejo at some point in automotive. And if I haven't worked with them, I can find somebody that works there. So I've worked with Magna, but I know a person that is a director of packaging there. So yeah, it's a very small, automotive packaging world is very small. And I have a map. Okay, so this is global versus North America. So you see Magnus jumped from number 3 to number 1. All right. Denso went from 2 to 3. ZF went from 5 to 2. Continental didn't change. Robert Bosch dropped from 1 to 5. Lear wasn't on, well, Lear's number 9, but now it's on the chart at 6. Flexingate was not on there, but they're a big North American supplier. Same with Panasonic. As you're seeing more and more electronics, you're going to see companies like Panasonic. ASIN, I forget what they do, but I have worked with them. Adient, I work for them. They do seating. So when I mentioned the seating plant, I work for them. So they're one of the largest seating suppliers. Lear is also a big seating supplier. So Lear and Adient are competitors. And I know that there is at least one other company that is in the Detroit area that is working to supply the seats as well. Okay. This is a picture of what the suppliers look like. So these are for parts. You can see it's really concentrated here in Detroit, concentrated in Michigan, concentrated in Ohio. You'll notice the concentration goes down I-75. And then you'll notice there's like another concentration goes along here. This would actually match up with the highway map. These are some of the original suppliers. There were a lot in New York for a while. There are still quite a few in the New York area. But there is a new concentration in the Southeast, what's called the Southeast Corridor, between like the Carolinas all the way to Alabama. There's a highway here. You can actually see this highway that runs right here. So one of the key interesting things about having these suppliers on these routes, you'll see they run along highways because it's easier to get to. For example, it's much easier to get up and down I-75 and get parts, even if you're getting all the way down to like Florida or Alabama, than it would be to get parts from North Dakota. So, you've got part suppliers here, but you see they're much more sparse. Much more sparse. But you could take, you probably map some road maps here. I'm pretty sure this is I-80 right here. And then I-10 runs along here. But it's strategically done that way because they want to be along highways so that they can distribute the parts and get them to and from to their suppliers. I'm sorry, to their customers faster. And if they're getting parts, because a lot of these companies are feeding. So if you look here, this shows like the number of suppliers. So here in Detroit, they've got, a whole lot more, and they're probably going to be larger companies. These companies here that are kind of scattered out through the middle of the US or even up here in the New England area, they are probably smaller suppliers. Might be some kind of custom, or there's some kind of part that they're the only ones that make that part. Same thing with here you've got LA. The reason why you're going to see a concentration here is because maybe there are ports here that are coming from Asia, and a lot of parts are coming from Asia. So they've built locations here that can accept their parts from the port, and maybe they're doing some final assembly. One of the things you'll see in American manufacturing, when they'll say something is made in America, it's usually they get parts from, most of the supplier parts are coming from a lot of the same people. If they're coming from overseas, they'll bring those parts from overseas and then assemble them together. And then they say that they're, made in America, and it might avoid tariffs. It might, for whatever reason, might be cheaper. There might be some advantages for them that do it that way. So what you'll see here, and like I said, they may not have to go through some of the customs and border paperwork and issues that they might encounter if they had an assembled part that came from overseas. So that's why you also see a proliferation of manufacturers here as well. I'm trying to think of where else. Okay. Texas, you'll see these in Texas, right? Because there are a lot of suppliers in automotive that are in Mexico. I have another map that shows Canada, but the same line of dots that you see in the US, you will see a line of dots here that go up basically through Ontario, Canada, because a lot of them a lot of these companies have built manufacturing facilities between Detroit and Toronto because it's pretty quick to get to. There may be differences in labor, but for whatever reason it is, contracts for unions, who knows? I don't know all the reasons, but you will see certain areas where there are, groups of suppliers. And that's usually a lot of times it has to do with, border crossings to get to Mexico, or getting to and from Asia. So you see a good number that are along the coast, because we have a lot of Asian manufacturers. And then here's probably going to be ports that are supporting European suppliers as well, because we get quite a few parts and vehicles even in from Europe. So this East Coast might be supporting some of those ports. Probably like here, I think this is probably going to be supporting Mercedes, BMW, those sorts of companies that are coming from Europe. Okay, so this here says to share expenses and profits, auto manufacturers engage in partnerships. To an extent, they do that, because a lot of the parts are either very similar or the same. A perfect example of this would be airbags. So airbags, I don't know if you remember all these airbag recalls that we've had over the last 5 years. That's because only 1 or 2 companies make the airbags. And the airbags in all these different vehicles that they were having recalls on, they were from one airbag supplier. So even though you're hearing, Chrysler, Toyota, Ford, whoever it was, you were hearing the different companies, but the airbags were all coming from the same supplier. So a lot of that is what you're seeing. And it helps them to save money because now they're ordering the same part or very similar part. Things like the wire harnesses that are used for the electronic components in the vehicle behind the dashboard. A lot of those are very similar. They're coming from 1 or 2 suppliers. Things like a cup holder or a DVD player. The DVD players, they may all have the same screen size. Those screens may all be the same, but the outer fascia of that or how it hooks onto the seat may be a little bit different, but they're able to, share expenses by doing that or save money or get a better price because now that everybody's getting that screen or very similar screen in bulk. So that's just an example. I don't know if that's a real case, but just it's an example of, you'll see those things a lot in automotive. When I work for the seating manufacturer, they might use a very similar frame or the post for the headset, the head rest for the vehicles. Those posts were all very similar, or the clips on it were very similar, no matter what the vehicle. If you look at different vehicles, you'll see things that look the same. And then if you really do some research, you'll find out they're made by the same company. So this is very similar to what you would see with private labeling with food, where it's the same food, same formula, almost exactly, and they just put them in a different carton. This has a different logo on it. So that is the thought process that they're using to, save money. Let's see, I touched a little bit upon the tiers. So I already mentioned OEM would be the original equipment manufacturer that makes the vehicle. But then you've got tier ones, and they are the ones that supply directly to the vehicle manufacturers, right? So here it gives you an examples of, windshield wipers. I mentioned the engine, seats, those things are being made and sent directly to the OEM, to the automotive plant. Tier 2, they are providing their supplier to the tier 1s. So an example of that would be, so when I work for seating, would be frames. So the metal frames inside of the seat or the cushion that goes on top of the metal frame, those things are the clips that go on the headrest, or even the post, the pins that are used to adjust the height of your headrest. Those would come from another supplier. And then, or let's say a mirror, right? So you have the mirror that's a, you know, you can change it from day to night vision, or maybe you have the system that you can call for an emergency on your mirror. The tier one would be providing that mirror to the vehicle company. Tier two might be providing the actual mirror and the outer casing. You know, those suppliers would be supplying those separate parts. But then a tier three supplier might be the company that is providing the plastic for the outer casing that's being injection molded, for example. Or I mentioned the frame for the seats. So the supplier that provides the frame to the companies making the seats, and that seats shipped completed to the automotive manufacturer, when they get that frame is going to be, you know, the sheets of metal will be sent to them, and then they will, you know, stamp out and shape that steel. So the people that send them the sheets of metal, they would be considered a tier three. Okay, this is touching on expendable versus returnable. So here are some examples, right? I gave you that one already. So you got a box versus a tote. You've got a crate versus a bulk bin, or a crate versus a rack. Some companies do try to reuse crates, but I personally wouldn't necessarily recommend that, because crates can be really difficult to build, and they can be really difficult to disassemble and break apart and take the part out. And if you've got a crate that is easy to take apart, it's probably not going to be very robust if you reuse it multiple times. Here's an example of boxes in what's a pallet load, or a pallet load or unit load of the returnable totes that go on a pallet. So in my example, you've got the pallet here, returnable pallet. You've got these trays might go inside of a bin, and then this bin is a bulk bin, so it could be picked up by a pallet and moved. But sometimes you'll have smaller totes, and those parts might go into the tote that way. So one of the things about automotive packaging is that the packaging is used, and you probably noticed in some of these pictures as we went through the line. I wanted to note that as we looked at those pictures, one of the things that's really important about automotive packaging is that the packaging is used by the operator or the assembler in the manufacturing plant. So it holds the packaging will hold the part, so they can reach it very easily. It's used to store. It's not only used to protect or transport, but it's also used for them to help them to what's called pick the part from the packaging. And it increases the speed for their assembly, because they don't have to go and, you know, find the part, go get it from the package, dig it out of the package, and then put the package back down, and then take that part over to the line. This pack is generally going to be right at the line. The operator can just grab what they need. And then when this is empty, someone magically shows up and takes it away. They may have somewhere where they set it down so that it went to know it's empty, or they might have a way to indicate this is empty for someone to come pick it up, but they don't have to like call and wait for someone to come get it. It will either be in a designated spot, or they have some flagging system for people to know that it's empty and to get it out the way and bring more. So a lot of times too, before I forget, when they take these empty containers, Usually the quantity of parts in the container is based on, it's usually some multiple of what's produced. So, you know, they mentioned about making 72 an hour. So what's in this bin would be either a multiple of 72, so 72 times 10, maybe for a 10-hour day, or it might be something that's divisible, you know, from 72. So let's say you might get 9 in a pack. So then they can say 9 in a pack over 8 hours, 72. So we're going to have, you know, 9 in a tray, and we're going to have 8 trays inside of here. So we know this is going to be a day's worth of material, an 8-hour shift. So a lot of thought goes into making sure that whatever quantity is in here is going to match up with production, so that they can know, okay, well, if I have 8 hours worth of material in here, then I need to deliver a new one of these every 8 hours or every 7.5 hours or whatever. And it will be ready for the operator just in time when they need it. Let's see. Okay, so I mentioned about how these get filled at the supplier. They go to the customer or the assembly plant, whoever the customer is that's going to be using those parts. When it's empty, I mentioned that they have a place to set it, or someone will come and magically get it. When they're magically getting it, because since it's a reusable pack, it gets put back on a truck and sent back to the whoever originally put the parts in there. So it comes back to them empty, and then they will ship it, fill it up again and ship it, and that whole cycle repeats. So that is what's that is what is called a closed loop. So there are a lot of ways to do that. It could just be a direct from A to B, or it could be A, B, C. It could be A through E, and they're just running in a circle all day. There are a lot of different ways they can do it. But it was done to get rid of waste. And again, you'll see that in the video later, that where they talk about what it was like before and after. But it really helped to eliminate a lot of the waste in the plants by doing that, and save money. Okay, so I'm going to talk a little bit about expendable versus returnable packaging. Any questions, Brandon, before I go any further?
Nope, I'm all good.
Okay, so advantages of switching. If you're switching from the expendable pack to a returnable pack, the first thing is, I mentioned before, not much waste, right? So the second thing is, though, when you look at the price of this might be $10. This might be $100 or $50 or whatever it is. It's going to cost a lot more. However, we'll do the return on investment calculator later, and you're going to see that over the period of time that you're using these, it's going to cost a lot less than this in most cases. There may be some exceptions, but in general, if you got a higher volume and you do the calculations, you will see it costs a lot less to use a returnable pack versus an expendable pack. The returnables also last longer. So, I mean, you can see from my little mini sample here, you can already see that it's broken, right? It takes a lot to break this. Like, even if, you know, for a full-size pallet, they're reinforced so that if a fork truck hits it, it's not going to splinter the wood. And they're just more robust because they're made to last longer. And if you have something that is prone to like getting crushed, the compression strength on this, again, this is 1/10 of the scale, right, of this container that I have. But the compression strength on a full-size container like this versus a box is going to be superior. So if you're looking for something that can't be crushed, you have a part that you're trying to pack, you would definitely want to consider something that is a returnable or pack that is more robust, that has a higher compression strength. Here, I tried to update this. This shows some different pallets. So, I mentioned if you have a hardwood, like an oak pallet, brand new versus pine versus plastic, you see the difference in the cost. So you can range from anywhere from $20 to $100. And some of the, I don't know what the pricing is now, but when I worked for one of the automotive companies, they had somehow worked out, their purchasing company worked out, they were paying like $5 a pallet. I'm sure that their price is at least double by now, but they were paying way less than most companies because they were buying so many of the pallets. When it didn't matter if it was, like their wood pallets. And then for their plastic pallets, they were probably paying like $50 for them. So they were getting a really good deal. And as prices went up, they were making their suppliers absorb or lose the profit, whatever profit they had. They were paying the difference. If you look at the life of these, okay, so if you refurbish a wood pallet, then it could be $15. Wood pallets aren't necessarily as robust. And if you're shipping them overseas, sometimes there are issues with, there are certain stamps to make sure that they're not contaminated with bugs. And we can talk about that later too. But that can be an issue. You don't always know the history of the wood that's being used. So sometimes the wood may be contaminated, or maybe it got wet, it's not as strong or warped. So, a lot of people might shy away from refurbish, but if they do, they might pay $15 right now for it. It's about accurate. If you look at how long these last, you could use a hardwood pallet, maybe 25 times. A softwood pallet is going to be more like, 2 trips and then it's gone. And these are probably going to be like some of the pallets that you see people take and they use them for tables or beds or, on Instagram, and they're, refurbishing them. That's probably what you're going to see. You're going to see some softwood pine, because those are going to be easier for them to work with too. For someone just grabs a pallet and then they want to start nailing on it, it's probably going to be a softwood pallet. But if you have a plastic pallet, you could use this up to 100 trips. And that's probably a conservative number. They're probably using it more, even if it looks bad, it's dirty and it's chipped, they can still use it. So if you look at the difference in the cost per trip, a hardwood pallet, like an oak pallet, it's going to be just over 35 cents, right? The softwood pine, it's only, it might be $3, but it's only because you're using it twice. But then the plastic pallet, it's 60 cents, which is going to be more than your hardwood if it's a one-time, if it's a smaller volume. But once you start getting the bigger volumes and you're not reusing these pallets, you're going to throw them away, it's going to start costing you less over the long run to use plastic. Another advantage of returnables is that they are standardized. So you can you have standard packs and standard pallets, and they're going to fit together. And when you have these standards, you can start planning for, okay, I know this is always going to go in a 12-inch by 15-inch tote. That's going to be your footprint on here. But sometimes I'm going to use this as an example, right, with these trays. This tray, for example, if they use a standard automotive pallet and they put this on the tray, I'm going to just do it this way so you can see. These are 2 across. You can see that there's overhang on that. Or if they just use 1, it's not going to really fill up the whole pallet. You're not going to get that many on this pallet. So, and it's going to fill up. You can only get 2 of these on a pallet. Versus if you were to cut this tray and make this tray like 1 row shorter, you could get 2 of these side by side and you could fit 4 of these trays on a pallet versus 2. You know, you get 2 of these on this side without any overhang. But if you put 2, you're going to get overhang on 2 by 2. If you put 4, you're going to get some overhang. So, you know, those are some things that you want to keep in mind. If you're using returnables, it's standard. But if you try to, you know, someone brings something that's not standard and they don't know those automotive standards, then they're not going to necessarily maximize that pallet out. This says if worldwide standardization of returnables can be achieved, transportation and handling costs will decrease because compatibility problems with packaging, handling equipment will disappear. That is true. However, just the sheer fact that we have, we don't use metric in the United States and everyone else uses metric, we probably will never get to a standard, a worldwide standard. There could be a worldwide standard except for the US, but there is a pallet that's called a Euro pallet that's very similar to the automotive footprint, but is not exactly the same. So those are just things to keep in mind. Yes, technically that's true. And people have been driving to that for years, but I think the fact that we don't use the metric system makes that a little bit more challenging. This talks about returnables being able to interlock with each other. And this would be an example. So Brandon, you can see my examples, okay?
Yep, I can see them.
Okay, so you see how you have these 2 bins and at the bottom they have feet. And at the top they have little nubs. So when you put them together, it would take a lot of force to pull them apart. So as they're traveling on a fork truck, they're going to hit the nub and not just slide off. So they're made to handle that. And even this one here, even though this is a different supplier, this pallet, because it's the same footprint, it's still made to hit those nubs. So it's a lot harder for these to fall apart or not stay together. So because they all have the same footprint, they know they can, you know, put features down here that will capture those nubs somehow, some way. Okay, so they can be made to, or they can interlock, or they can nest. If they collapse, some of these aren't collapsible, but for the ones that collapse, you can actually collapse them, fold them down, or you can stack them on top of each other. I'm trying to think of totes. You know how you see totes? I don't have any here, but you have totes that you can stack and they'll nest in them when you're ready to pull them out. They're usually angled. You can pull them up and use them, but you can store them all together, kind of like chairs. You have folding chairs or chairs that are stackable. They're made to stack together. And returnable packaging is made like that too. So you can save room when you're shipping back, because the cost to ship these back is more expensive because they're empty and no one wants to ever drive a truck that is almost all air. They don't want to, no one wants to ship a truck full of empty packaging. It's not as profitable. So if they can shrink them or fold them down and get more on a truck, then that makes them happier. Okay, number 7 is one of my favorite ones, right? Returnables can be color coded like this. And they're sized and shaped for identification purposes, because what happens is you get a company and they're getting, these are the exact same size bins, but they're different colors. So when it's time to return them, if they don't have a good like lean manufacturing process in place, they will just take all of these are the big bins, and they just take all the big bins and they put them on the same truck. So then supplier A gets twice as many as they need, and supplier B doesn't get any. So now supplier B is calling and scrambling and saying, I didn't get my containers. And they're like, we sent them out. Well, they did send them out, but they they didn't bother to take half and send them to one and took it to the other, whatever they were supposed to send. So then someone came up with the idea of color coding to say, okay, supplier A only gets blue, supplier B only gets pink. That doesn't always work either, because that's dependent on the discipline and the processes of the people that are loading the truck. And so it just depends on, how they've been trained, what they know. So if you might color code them, if no one ever tells the trucking people that are loading the truck, blue goes to supplier A, pink goes to supplier B, they don't know, they just put everything on the same truck. So it's important to make sure that if you do something like that, that is very well known, everyone's trained. If when there's turnover and new people come, you got to make sure that they understand these things. Because mostly when they get trained, they're just told, put the big bin on the truck. They're not told put the pink bin on one truck and the blue bin on another truck. So if you ever walk into a plant and you see they have every single color of packaging you can imagine, that usually tells you that they probably need to work on their processes and training of the people in their plant. And then sometimes you'll get suppliers or, your supplier, just to be safe, they'll ask for extra packaging so they don't ever run out. And then what they'll do is they'll build this packaging, they'll build the parts, put them in the packaging and store it. And then so they're basically like taking someone else's containers. But we'll talk about that later. Let's see. Returnables are good because they do help with like taking a part out, because they can be designed to hold the part. Let's see. I don't know if you can see. I don't know if you can really see this really well, but this has it's like a tray and it fits parts in it. And that can help because now they're oriented the same way. So if this part needs to be put into the vehicle the same exact way, they just pick it up out the tray and it's fit. They just stick it right in and it's in the right orientation. Versus if they didn't have a tray like this and it just gets put into a tray, a bin, and it's in any direction, now the operator has to pick it up, look at it, and then orient it and put it. And that, what seems like a second of time, if they're doing this all day for over 1,000 parts, that adds up over time and it slows them. They're not going to be able to do as many as they could have if they just pick it and put it, pick it and put it, versus pick it, look at it, turn it around, and then put it in. Oh, wait, put it in the wrong way. And then they're trying to fit it. So just little things like that. It really does add up. Let's see. So we talk about lean production and having this flow of containers being picked up, delivered to them, the right amount at the right time to the right place. That is something that you can do. If you set your processes up right, you can do that really well with returnables. Number 10 is listed as an advantage, that you can manage your containers by third-party logistics, which I've seen it work really well. When we get to this about rentals, I will tell you what the theory is, but then I won't tell you my personal experience and my personal opinion about some of these companies. So let's see, disadvantages. We've got the containers can be sitting at someplace we don't know where it is. I showed you that picture where we have the plant where when they're backed up, the trucks can be all the way wrapped around the building. Well, that's all going to be holding parts in packaging. So once that backup occurs, now the people that put the parts in the packaging to ship it to that plant, now they're going to, at some point, they're going to run out of packaging. So keeping that flow going is important. Knowing how many you need, knowing what could go wrong, because you've got to account for what could go wrong. You've got to understand your process and what could go wrong or what's slow in order to do that right and do that well. I mentioned about nobody wants to have to ship a truck full of empty packaging anywhere because it is expensive. It doesn't add any value, but in the long run, it can be cheaper than buying expendable packaging over and over again. Keeping track of a container inventory. I already talked about that, about how, if you do it well, everyone knows where the blue bins go and where the pink bins go. But if you don't do it well, who knows where they're going? They literally go everywhere. If you go into an automotive plant, you may not have noticed this, but you will notice it now or after this course is over, that you will see containers. They all look the same. They're all like a green tote, but when you look at them closely, it'll say like Toyota, Honda, GM, Denso, all the suppliers, OEMs and suppliers. You'll see all different names on them because over time they've mixed them up. If you change the part, it may not fit. This is true. And this is true not only of shipping the parts into the assembly plants or shipping them from one supplier to the other, but I've seen this going out the door, finished vehicles. I work for a company that made vehicles, and the engineering team decided, with the marketing team and engineering decided they were going to make big wheels on the vehicles because that's popular, and it kind of have rims on them, and they were going to be, really popular and people going to buy them. And they did, the sales went up. However, they did not think or know, there was no history on why, but years ago, the size of that vehicle was limited because they could get two of the finished vehicles side by side in a truck. Like exactly, just perfectly fit them in. And when they added the big wheels, they couldn't do that anymore. So what they ended up doing, the workaround was to take the wheels off, put some little baby tires on, and then put big tires, to ship the big tires separately. So now they've added a whole new process to that. So that would just be an example of making sure that as a packaging engineer, you understand what part revisions they're having, and that does it affect what's called the form or the function. So an example of a function change would be maybe you have a CD player, a DVD player that goes behind the headrest, and they maybe made some changes in the wiring or the software so that the movies boot up faster when they stick the video in there, or maybe it's a Bluetooth or something, and they make some change to improve that. That would be some sort of change in the factor that change it, but doesn't change the shape of the packaging or anything. It probably doesn't change how fragile it is either. But a form change would be something that changes the size. And sometimes, make the tires as an example where it didn't seem like a big deal, but no one brought packaging into it. But if, as a packaging engineer, if you work in automotive, you get to know the engineers, you get to know manufacturing, you get to know the program managers, you get to know everyone and be part of the team, you'll hear about any changes before they happen. So if they're just talking about, maybe we should make the tires bigger, and it's going to look great, then, you're like, but will this fit in the truck? And you can, figure that out early on. See this last one, number 5, they tend to be plain, yeah, but you're not really marketing or anything. Nobody really cares. Let's see. Your containers are going to be heavier, they corrugated, but most of the parts are more industrial and heavier. So many times they're pulled on tuggers or carts or fork trucks. So you aren't really carrying much by hand anyway. And 30 pounds is going to be a limit in general in most automotive plants. And I think I want to say OSHA, their cutoff for carrying a package is for a person is like 35 pounds, but because automotive has had such strong, labor support with the unions and everything like that, and they were really good about people not getting hurt, their requirement is a little bit lower. than the national average of 35 pounds. It's like 30. But you also, because returnables are heavier, you can't get as many parts in. So you can probably get more parts in a box, because a corrugated box weighs a lot less than a plastic container for the same size. Same thing with the cube. So they might have a different weight, but you'll see here that this wall is going to be thicker. So the ID versus the OD is going to be significant. So you have to accommodate for that ID. So even though this is, I'll just say it's like it would be a standard 48 by 40 inch tote or bin that's like the size of a pallet. The side wall is going to be much bigger. So you might lose an inch or 2 inches or something like that on a tote that big. And then you don't see as many tapered returnables, but some returnables are tapered, so you're going to get even less in there. Says containers must be eventually cleaned. Yes, that is written in most contracts, depending on what it is and what they make. Generally, they don't get cleaned unless it's in a really oily product or a product that has like metal shavings, or a product that goes into a clean room, like a sensitive electronic part, then they'll get cleaned. But most of the time, if it's just like, seat belts or door handles, these won't get cleaned. And if it gets to the point where it's really bad, somebody will come up with the idea to just bag them and put them in the dirty containers. So just keep that in mind. Let's see. Wood, paper, corrugated, yeah, they're considered to be, I guess, less combustible. You'll find that where they might stack maybe 3 or 4 high for corrugated, if you're in a plant with these plastic containers, there's usually some limitation that the fire marshal has for how high they can go, and usually it's below the sprinkler system in the building. So you may not be able to stack as high. Because they can be if there's a fire, the smoke is really bad. Okay, we're getting close to time, so I'll finish this later, but this is next time. Tomorrow we'll talk about how the auto industry has decided to move from expendable packages to returnable as much as possible. Like this has been going on since the 80s. It's pretty standard, but I found that lately people have tried to get away from it because people hate plastic. But once they start running the numbers, the finance team says, no, we're using plastic. So, and you can reuse them. Like I said, we'll talk about some of the sustainable things that people are looking at to help with the automotive industry. I'll make sure you guys get that reading because I think it's really interesting. What else do I want to do before I close? I just wanted to talk about the homework a little bit. Let me pull this over. This is what most of the homework looks like, okay? So you guys might be able to see it. It's small for me. So, you're just going to have questions. It's just a, basically an essay type of answer. Every once in a while, you might get a, you might get a calculation, but for the most part, you don't. Okay, so I think they're actually for number 10, I think you're going to have 2 videos about the Rouge River assembly plant. One is listed in the verbiage that's in chapter 1, but then at the very end, I put a link to a full video of that. So I'll double check that and just clarify that. But yeah, if you can answer this in either Word or Excel, I think generally most of these you can answer with Word. Typing into Word and just submit your answers via D2L. If you have any questions before you turn it in, let me know. And I'm happy to answer any questions you have. If you have any questions on terminology or anything like that, just, let me know as well. I'm will try to stay mostly with the notes, but I also will give as many examples as I can about what I've actually seen in automotive. And hopefully that will help you all relate to some of the things that are written in here. So it's, real life, actual, some examples of things that have happened. And then I mentioned before that my office hours are Fridays from 4 to 5 Eastern Standard Time. But if you want to schedule another time for office hours, you can email me, and the regular office hours would be via Zoom, and we'll figure out if you can't do Zoom. If you have to schedule separate office hours for anything, let me know. What else? If you have any questions on the reading, just, again, feel free to talk to me. I will try to post them all up, but I just want to make sure everything's up to date and add things to the reading, but, try not to read too far ahead, and focus more on what we're doing, unless you just know that for some reason you're going to be out of pocket for a particular week, because I know a lot of people that are in this class, my understanding is that they're doing internships. So I know you are, Brandon, but other people are as well. So try to accommodate your schedules, but, try not to work too far ahead unless you just need to. Let's see. Those are the main things that I have. So Brandon, now that we've been through the first day, just want to make sure we have everything. I'd like to get your feedback, questions, anything that you would like to see or clarify.
Yeah, I liked it so far. Everything was nice. Try not to use my regular verbiage here, but everything's been nice so far. I like the use of examples and everything, definitely with the industry experience, because a lot of the time I understand things from an industrial aspect rather than the academic. So definitely like that.
Okay. Okay. So I think that is it. I mean, we're a little bit, got 3 more minutes, but I just wanted to leave it open for questions. So I'm trying to think if there's anything else that I missed. Yeah, I mean, so really tomorrow we're going to go through, I plan to, finish up chapter 1 by Thursday. If we get done early enough, I might play some of the one of the videos. We'll give you a link to the video so you can see it. But like I said, I'm a nerd for packaging and I'm a nerd for automotive. So, I can sit and watch these videos about automotive packaging all day. So that's why I'm asking for you all's feedback, because I just want to make sure that it is relevant to you all. So that is what I have for now. And I look forward to working with everyone. Okay.
All right, sounds good.
All right. Thank you. And I will talk to everyone tomorrow.
All right,
All right. Bye-bye.
peace.